This section is about energy. Let's examine two forms of energy, kinetic and gravitational potential energy. Kinetic energy is the energy of motion. You have to be moving to have kinetic energy. And there's a formula for it. 1/2 mv squared, where m is the mass and v is the speed. Let's say that two objects are located near Earth, A and B, but B is 4 times as far away from the surface as A is. Let's let them be both held here motionless at rest for a minute. How much kinetic energy do they have if they're both at rest? Well, because the speed would be 0, their kinetic energies would be 0 as well. But now, how much potential energy do they have? That's a little bit tougher question. So imagine this analogy. What if you were to hold a book 1 meter off ground and then hold an identical book 4 meters off ground? Which object has more potential to do damage if it drops, to make the loudest sound? Which one will be moving fastest when it contacts Earth? Well, I think we can all agree that the object that's held farther away can do the most damage. And one explanation for that, it's a little thought experiment, is imagine just releasing ball B from rest. What would happen? It would be pulled on by the gravitational field. And by the time B gets to A, B is moving, whereas A is not. A hasn't been released yet, let's say. That's one explanation for why B has more what we call gravitational potential energy. Okay. So what happens here is potential energy gets transformed into a new form. The object gets pulled on and gets accelerated, so it loses the potential energy that it had, but it gains kinetic energy. Now, when these objects do finally hit Earth, it should be clear that A will have just got going, whereas when B hits, it'll be moving very fast. And that's one explanation for why B could do greater damage. Now let's check out two objects which are held from the same height above Earth, but they are different masses. As you can see, mass is part of the formula. Let's let them be at rest at the start. Okay. Now, let's assume that they're both going to be released simultaneously. We know from our past of dropping heavy objects and light objects together that they will actually travel side by side. And they'll pick up velocity with the same amount. So they'll be traveling the same speed as they move together. So they're going to hit Earth with the same speed. But it's not just about speed here. Imagine you hold a 1 kilogram mass above Earth, maybe 1 meter above the surface, and then you hold a 20 kilogram mass. Which one's going to do the most damage if it falls? The 20 kilogram one, right? And so, yeah, this one's going to have larger final kinetic energy when it hits Earth. This one will have the smaller kinetic energy. It's because of the formula, too. 1/2 mv squared. So if the mass is doubled, then the kinetic energy is doubled, too.